Hello everyone, my name is Nicholas Lantz and I'm the project lead for GKN Inspect. The goal of our project is to automate the inspection of automotive pinions to decrease unnecessary pinion handling by quality control operators. Some of our requirements include pinions accurately failing when there's a manufacturing defect, cracks being recognized during the visual inspection process, and an audio and visual cue being present upon completion of both good and bad parts. Our station processes include first, the input of pinions, which are input into a go gauge to check the splines. This is followed by the operator start process, which includes a light curtain for safety. Third is a visual check completed with a smart camera. Next is a laser micrometer check on the bearing ODs. Fifth is a bearing OD check to further inspect two outer diameters of the pinion. And finally, the process ends with the delivery of the pinions to the good and bad outputs for the operator to grab the parts. Our station components include the gantry, a Siemens S7 1500 PLC, two Siemens power supplies, along with two other power supplies to power the motors, an electrical cabinet, NEMA 34 steppers and drivers, and a Cognex D902M smart camera running a machine learning algorithm. As said before, the machine uses a Siemens PLC, and this will be programmed with Siemens TIA Portal version 17. The PLC will control two I/O banks and receive and control signals from the stepper motors and drivers, the inductive sensors, laser micrometer, the HMI, and the emergency stop. Here's the station overview. At the bottom, you can see the part input along with the good and bad part outputs. The bad output is separate to reduce complacency. In addition, there's the HMI on the left, the electrical cabinet, which will house the PLC and some other components, and the XYZ gantry with the gripper in the top left that will be mounted to the bottom of the gantry. Here are some of the different checks. You can see the pinion where it goes into the go gauge, followed by the laser micrometer and the bearing journal check, along with the good and bad output holders, and finally the camera assembly. Currently, all designs are complete with some items already purchased. We've also received some items such as the PLC, HMI, and several power supplies. Next semester, the plans are to have all parts machined by the end of February, with testing beginning in April, followed by the final Expo, and all testing being complete by May of 2022. Here are references, and these files have been created by the team.